Hello, this is an attempt to illustrate the guidance to do the CompTIA Linux Plus certification. And these slides actually I'm going to present, and also I will be presenting some hands-on exercises over next few weeks. These will be taken from Jason Eckert's CompTIA Linux Plus Guide to Linux Certification 4th edition book. So all credits goes to the author about the book and the slides. No originality is claimed here, but I'm just merely trying to explain it and make the content available for free for understanding. So the main objective of this course is to first of all explain the purpose of an operating system, then outlining the key features of the Linux operating system, describe the origins of the Linux operating system, identify the characteristics of different Linux distributions and how can we find them, where do we get them, and then explaining the common issues of Linux in industry today. So first of all, we are talking about the operating system. So we all have a device, the computer. I'm also presenting these slides from a device. Now this device has hardware, and then we have the software, right? I mean, each computer, each device we call today, I mean, that can have a hardware and a software. So hardware is the physical components inside a computer. Uh, Anyone who learned a little bit about the electronics, the physics, electronics, physics of the electronics, I mean, all those things, they learned a lot of things related to the digital circuits, the integrated circuits, I mean, all important stuffs. So hardware is basically those, I mean, those electronic components, the physical components inside the computer. And the software is a set of instructions or programs that would let the hardware components work to manipulate the data. So basically, using the software, we drive the hardware. You know, the software traditionally has two purposes. Number one is digitization, and number two is automation. So when we have a device, we have to install their, I mean, we have to have their hardware, and then we have to install some kind of software so that that software component can drive the, or can digitize and can automate the steps that should take place in order that that machine processes the information properly. So the operating systems is a complex machine. So operating system has basically two uh, different concepts. It is built on two different concepts. You know, number one is the abstraction of complex software components, or visualization of the hardware components in a simple way so that the user can interact with it, a human can interact with it. I mean, if I give you an integrated circuit and ask you to do a calculation, it will be hard for you. But if you have a software layer, an abstracted layer, then it will be easier for you, right? We can press the buttons and do the calculations really fast. Then the second part of the hardware, I mean, operating system, is the extended machine, because it has the user layer, you have the keyboard, all those hardware components, you have the operating system software, and you have underlying hardware, clocks, the memory chips, all complicated components. Now inside a computer you have many hardware components, mainly, like, you know about this processor or CPU, the physical memory or RAM, random access memory, hard disk drives. You can have multiple type of magnetic disk, or you can have those solid state disks today, solid state devices. You have CD and DVD drives. Those are these days those are becoming obsolete, but still those are used somewhere, right? And then the flash memory card readers, sound card, video cards, and of course the circuit boards. Uh, so two different kinds of programs we have in the operating system to be executed. The apps, first of all. So those are the software components, applications basically, that a user can use to accomplish certain specific goals. Like I mean, you can have the Microsoft Word, for example, on your machine, or on the Linux you can have LibreOffice. So that's an app. So in the LibreOffice you can have you can create your deck, you can create your document. I mean, you can do multiple things. Now you can, I mean, the second layer of the programs is what is constituted by what constitutes the operating system. You know, the software component used to control the hardware of the computer. Now, even in the operating system you can have I mean, even other than operating system you can have the device driver. um, I mean, those are the software containing instructions that the operating system uses to control and interact with specific device. For example, you can use the device driver for your printer. You know, the first thing that we do in order to install the printer is to download the specific device driver, so that your operating system can issue a print command, but it has to have some interface between the operating system and the actual device, right? You cannot recompile and recompile your operating system program to fit devices. You have an interface. Then the device driver is the one that contains the detailed implementation of the functionality of your devices. And then you can have the user interface, graphical user interface, or GUI. I mean, and this is an application program that accepts user input indicating what needs to be done, uh, and then it relays that input to the operating system for completion, and it gives the results back to the user. It can be a command line prompt or a graphical user interface, right? I mean, on a Linux system, for example, you can have different windows, right? You can have Firefox, for example. That's a internet browser that provides you with browsing facility. So that is done by the GUI. That is that can show up as the GUI. Or sometimes you issue certain commands, and those commands can be, let us say we want to navigate to certain folder. You can accomplish it by clicking the folder on a GUI, or you can simply use your command line to navigate to a certain directory, a certain folder. So from the top, if you look at the operating system, there are different layers, right? It starts with the user, I mean us as the user. Then you have the apps, application software, and then you have the operating system. That is the core of that contains the core programs that drives the hardware, drives the entire computer, and at the very back end you have the computer hardware. So that's the view of the operating system. It's a top down view of the operating system. Now, graphical user interface is a component of an operating system that user can interact with using the keyboard or the mouse. System services, I mean, these are the applications that handle system related tasks, such as you can do printing, you can schedule the programs, you can gain network access. So those are regarded as the system services. So if you look at the Linux graphical user interface, it looks like something like that. If you have a Linux that is up and running on your machine, or even on a virtual box. We will talk about the virtual box later, but this is a snippet of a Linux window. You can see the file explorer. You can see different folders there, and also there is a editor. You can see this is the LibreOffice Writer. This is the Linux version of Microsoft Office. I'm talking about Microsoft Office just not because it is, I'm not considering it as a superior product or something like that, but I mean, majority of the users, they use Microsoft Office. We are so used to it, so we use the Microsoft Office suite for our documentation purposes. So Linux also has a compatible tool. Even sometimes they have more flexibility, more extended facilities. You can learn about it, but that's called the LibreOffice. So basically, it's a kind of, it used to be initially, if I think about the history, there used to be a Star Office, then that became Open Office, and now I see that LibreOffice. They are basically the same. But the beauty of LibreOffice, I mean, I'm just giving you some glimpses of that as we pass through these slides. The LibreOffice, the output file can be of different format, and the beauty is you can also create files. I mean, you can also export your file in the format of Microsoft Word document. So something you create inside Linux using the LibreOffice, you can send it to email to someone. They can open it using their Microsoft Office, Microsoft Word tool. Vice versa. I mean, I have, for example, if I send someone the Microsoft Word file, docx file, if the person I'm sending to is a Linux user, they can open it using the LibreOffice as well. Import. They have to import that. So I mean, that's the beauty of the intercompatibility between the Linux and Windows. We, after all, we live in a single world, right? So the Linux operating system, we are jumping into the Linux operating system. To be very specific, it's an operating system used to run a variety of applications on a variety of different hardware components. So you have a PC, you have a device, you can install Linux on it, you can install Windows on it, right? I mean, uh, whatever machine you have Windows on it, you can use the Linux there too. Just you have to get the proper source, the distribution, and get it installed. Um, the the main main feature of such an operating system, I mean Linux operating system, is that this is multi-user and this is multitasking. The main advantage, I mean the main important thing about Linux is you can use as a user facing device, as a user device, you can use as a server device. So it has the ability to manage a lot of tasks, thousands of tasks at the same time. It allows multiple users to access the system at the same time. So it's just like a Windows server, but the Linux servers are more flexible. I mean, you can buy you can install a Linux machine, Linux operating system, and distribute that system in the network, through the network devices, and you can set up a terminal, multiple terminals, and each terminal can a user can access the machine and they can work. So that's the Linux operating system. So Linux operating system has these components. First of all, there is a core component which is called kernel. The Linux kernel is the core of the operating system. So it is written in C programming language developed in the early 90s. Uh, and the beauty is that it is open source, means you can get the source code of the Linux operating system, the entire operating system. Now, the software can be used to modify appearance of Linux, but the kernel is common to all Linux. It's important to understand that Linux kernel version numbers it is important to understand the Linux kernel version numbers in order to decide which version is appropriate for the needs of specific users. The good understanding of system hardware is important for us to decide which kernel version to use. You cannot just bring any kernel and plug it to any user. I mean, it's just like Windows. You can have 64 64 versus 32 versions. So same thing goes for Linux as well. So Linux kernel versions are composed of major number that indicates the major revision to the Linux kernel. It has minor number that indicates the minor revision and stability of the Linux kernel. If odd, referred to as a developmental kernel, a kernel which is not fully tested and with implied instability. If even, the minor number is odd, then you have some experimental kernel, and if it is even, then it's a production kernel, means it's pretty stable. So that's a beautiful thing, right? I mean, you can identify Linux kernel versions in terms of the major and minor. Major is the major revision of the kernel, and minor number is basically represents the even number represents the production version, odd number represents some experimental version, and then it also has the revision number. So you can see a lot of examples right here. So you see that in September 1991, long ago, the first Linux kernel was developed. And now, as of 2014, it's old, still old. You have certain kernel version 3.16.2. Open source software, the programs are the programs distributed and licensed so that the source code is freely available to anyone who wants to review. They can utilize, or even they can contribute to it. The source code refers to the list of instructions that a software developer writes to make up a program. Format and structure of the source code follows the rules defined by the programming language in which it was written. Like you can write a C program, you can write a Java program, whatever. It should follow the format, syntax, the compilation process, the variable, and the allowed versus disallowed variables. All those conventional stuff in the language, not conventional, required stuff that is provided within the language. So the open source software has multiple implications. The software is developed very rapidly through widespread collaboration. By the way, sometimes people think that open source software is a free software. It's free. Of course, it's free, but the concept is it's not a free like a free coffee, but it's a free like free speech. It doesn't necessarily be costing $0 always. But once you get the license, you are open to modify it, enhance it, review it, all those stuff. Now, implication of open source software is that it's developed rapidly through wide collaborations. The software bugs are noted and promptly fixed. Software features evolve quickly based on users' needs. The perceived value of the software increases because it is based on usefulness, not on price. The licensing of Linux, it's a open source software in which the source code and software can be obtained free of charge and can be modified. Closed source is basically software in which the source code is not available. Although this type of software might be distributed free of charge, it is usually costly. Freeware, it is closed source software that is given out free of charge. Shareware, closed source software that is initially given out free of charge but that requires payment after a certain period of use. So there can be multiple types of open source licenses. Uh, there is a GNU public license, GPL. It was developed by the Free Software Foundation, or FSF. It stipulates that the source code of any software published under its license must be freely available. Users who modify the source code must also redistribute the modified code freely. Then you have the artistic license, open source software license allowing source code to be distributed freely, charged only at discretion of original user. Original author has the right to reject the changes, of course. The types of closed source licenses are: most closed source software is sold commercially, usually bears level of manufacturers such as Microsoft, Apple, or Electronic Arts. The freeware distributed free of charge, source code is not available. Shareware, it's initially free but requires payment after a period of time. Remember, like WinZip, you can download, but it will require you to acquire the license after a certain period of time. So the advantages of Linux is, first of all, it reduces the risk. Changes in the market or customer needs may cause companies to change software frequently. It can be costly and time consuming. Support for closed source software may end. The vendor may go out of business. Who knows? Software version may be retired. Open source software products offer the opportunity to maintain and change the source code. That's most important thing. It meets the business needs. Common software available for Linux includes scientific and engineering software, software emulators, web servers, web browsers and e-commerce suites, desktop productivity software, graphics manipulation software, database software, security software. Linux also provides stability and security. Customers using a closed source operating system must rely on the vendor to fix any problem, any bugs. So when you use a closed source product, you may need to wait for a hot fix, and that wait time may be weeks to months. The collaborative open source approach to testing and fixing bugs increases the stability of Linux. Bugs and security loopholes in open source software programs can be identified and fixed quickly. code is freely available and scrutinized by many developers. Linux advantages, that is, first of all, the flexibility for different hardware platforms. The partial list of hardware platforms on which Linux can run are, first of all, Intel x86, x64. You can have many things, like you can have mainframe, ARM, Alpha, MIPS. I mean, there is a long list. And Linux can be customized to work on mobile and embedded devices. That's another beautiful things. The the customization, in line of customization, Linux provides us ability to control the inner workings of the operating system. To use Linux as an internet web server, um, recompile the kernel to include only the support needed to be an internet web server. It results in a much smaller and faster kernel. We can choose to install only software packages needed to perform the bare essential tasks. Uh, the Linux supports several programming languages such as Shell and Perl scripts to customize or automate its tasks. Ease of obtaining the support is another advantage of Linux. The Linux documentation can be found on the internet openly. You have the frequently asked questions, you have a lot of how-to documents. The how-to documents are maintained by their authors but are centrally collected by Linux Documentation Project, or called LDP. You have multiple Linux news groups. You can have Linux user groups, open forum of Linux users who discuss and assist each other in using and modifying the Linux operating system. The cost, from the cost perspective, Linux is less expensive than other operating systems. There is no cost associated with acquiring the software. A wealth of open source software can be run on the machine on a variety of different hardware platforms running Linux. The largest cost associated with Linux is the cost associated with hiring people to maintain the Linux system. Total cost of ownership, overall cost of using a particular operating system. I mean, due to the cost reduction, I mean, the low cost perspective, Linux is so popular. I mean, if you look at Amazon Web Services, I mean, look at the cloud computing platforms, you will see a huge abundance of Linux systems. Is it just because of cost? Yes, I mean, cost is one reason, but there are other advantages that we discuss right now associated with Linux. So you have the operating system. So you see there is a calculation, I mean, some chart. Operating system cost is $0. So any other vendor related operating system is non-zero. The cost of administration is low because it's highly stable and bugs are fixed quickly by open source developer. The closed source operating system cost of administration is moderate or high. Cost of additional software is none, basically. I mean, those are also open source for Linux, but for closed source it's high. Cost of software upgrades is low or none. Closed source operating system is moderate or high. So if you look at the history of Linux, you can see the Multics project was developed in 1965. Then 1969 we had creation of Unix. 1973 MIT jargon file released. Finally, Linux came to the world around 1991. Linus Torvalds, that person created Linux. Its name is the name Linux came from his name, and then it developed very rapidly. And now look at it. I mean, it was up to 2014, but today also we have lot of Linux users, and that doesn't even include the Android users. The Unix is a very, Linux basically built following the Unix operating system, not from Unix operating system. It followed. It was inspired by Unix, so evolved from multiplex information and computing service Multics. The first true multitasking multi-user operating system was the Unix. It was written in the C programming language, rewritten, portable operating system able to run on different hardware platforms. AT&T sold Unix source code to several companies. Each developed its own variety or flavor of Unix, yet adhered to standards agreed upon by all. So you have for the Unix, you have the Berkeley software distribution version of the original Unix source code. You have the common flavors of Unix today that includes Oracle's Solaris, formerly CERN Microsystems. Then you have the HPUX from Hewlett Packard, HP. You have AIX Unix from IBM. You have OS X and iOS Apple Macintosh. So on your MacBook, you are running a Unix system. Do you know that? That's an important thing to know, right? Uh, the hacker culture. A hacker is a person who is a malicious, right? So, but you know, our definition of hacker is a malicious person, but it's not. A person who attempts to expand knowledge of computing through experimentation, that is called a hacker. Idea of sharing knowledge is fundamental to hackers. Hacker culture set the stage for the development of Linux. The cracker is someone who maliciously uses computer for personal benefit or cause the damage. The Richard Stallman, famous hacker who worked at MIT, formed the Free Software Foundation or FSF to encourage free software development. Remember the name Richard Stallman. The hacker culture, it gave rise to a lot of projects. Like GNU project, um, generally not Unix. So free operating system project started by Richard Stallman in order to promote free development for a free operating system that was not Unix. You know, GNU project led to publication of GNU Public License or GPL. It legalized free distribution of source code and encouraged collaborative development. This hacker culture of collaborative development set the stage for Linux. Linux was first developed by Linus Torvalds in 1991. It was published under the GNU license. Linux kernel was developed collaboratively and centrally managed. Hackers developed Linux add-on packages and distributions. There is a collection of software containing the Linux kernel and libraries combined with add-on software specific to certain use. Like Red Hat and SUSE. They are examples of the distributions, but you can have multiple. Like you can have Mint Linux, you can have Kali Linux. There are Linux like CentOS. Multiple version. So Linux is simply a byproduct of open source development. Since 2000, there has been interest in embedded Linux operating systems that run on smaller hardware devices like your phone. Because Linux is currently very well developed, more application development can be expected from the open source software communities in the next decade. So distributions may appear different on the surface but run the same kernel. Some distributions include a large number of server related tools such as web servers, database servers. Most distributions include a GUI that can be further customized to suit the needs of the user. Core component of this GUI is X Windows. So the X windows in combination with window manager and desktop environment affects the look and feel of the Linux GUI. It is called the X windows. Two components of GUI environment in Linux. One is the genome and another is KDE, K desktop environment, and GNU object model environment. Some Linux distribution include specific language support, for example, Turbo Linux with increased support for Japanese and Chinese. So if you look at the Linux distributions, I mean the genome desktop somehow looks like this slide, and the KDE desktop somehow looks like that. So that's the difference. So they are almost the same. The heart of the system, that is the kernel, is same, but the appearance, the look and feel are different. Customizations are different. So Linux is distributed through the package manager. Package manager is a software system that installs and maintains software. For example, you have Red Hat package manager. The most widely supported package manager is the Red Hat. You can have a Tarball. It is a compressed archive of files containing scripts that install software to correct location on the system. It's difficult to manage, upgrade, or remove from the system. Of course, the package managers have become the most common methods for installing the software. So you have different Linux distributions. Some examples are there. Like Red Hat Linux. You can see that the platforms and also the location. The URLs. You have the SUSE Linux, and you have Slackware Linux. Different distributions, different platforms, and different URLs are given. Now it continues, right? Debian Linux, the Ubuntu, uh, Linux Mint, Turbo Linux. So Mint is a new and easy to use Linux distribution. As a user, if you want to install it on your desktop, that you should choose Mint because it's very lightweight, and you can enjoy all the benefits of Linux without incurring a lot of CPU or memory costs. You know, so that's another thing about the Linux distribution. So mostly Linux can be customized to provide services for a variety of companies in a variety of situations. So for example, if you want to use it as a server, as I said before, you don't have to install a lot of rich UI GUI environment. You know, you can use Linux for the workstation services. You can use Linux for the server services. Linux configurations commonly used today, internet servers, file and print servers, app servers, application servers, the cloud systems. They use overwhelmingly in the supercomputers. Scientific workstation. Linux is extremely important, extremely popular among the researchers, the scientific researcher. Office and personal workstations, and mobile devices where you can use Linux as well. The most common internet services are the mail services, routing services, FTP services, firewall and proxy services. You can have web services, news services, and DNS services. So internet servers, the mail services, you can use the MTA or mail transfer event agent, an email server used to distribute email. Mail delivery agent, MDA service that downloads email from MTA. Fetch mail, proc mail, those are the examples. And mail user agent, um, program that allows email to be read by the user. You can use the Pine, a very legacy kind of mail user agent. Print mail, ELM mail, Netscape, and Eudora. Internet service servers, I mean, you can use the routing providers, provides the interconnection between different networks, core services necessary for the internet to function. Linux provides support for routing and is easily customizable. A router is a computer or a special hardware device that provides interconnection between separate networks. So can you call your Wi-Fi server as a router? The internet services servers like FTP services rely on file transfer protocol, most common and efficient method for transferring files over the internet. Most FTP servers available on the internet allow any user to connect, called anonymous FTP servers. Most operating systems are distributed with an FTP client program. You have the firewall and proxy services, more relevant to the security. It protects companies from outside intruders on the internet. Linux's firewall support built into kernel allows companies to control what traffic is allowed into their network. The proxy servers request internet resources such as websites and the FTP sites on behalf of the computer inside the company. Common proxy server used on Linux is Squid. The web servers host information. I mean, they can process programs known as Common Gateway Interface (CGI) scripts that enable common connection to a resource on the network which is not connected to the internet. Can use single socket layer SSL or TLS to provide secured connections. Many open source web server software packages are available for Linux. Most widely used are Apache Web Server. The news servers allow users to post messages in forums called news groups. Most web servers do not provide means for users to communicate. The news groups are sometimes referred to as computer bulletin boards. Open source software developers use news groups to exchange information and coordinate software creation. Most popular news server is available for Linux is called Internetwork News, INN. Internet servers, the DNS services, the computer communicating on a network need to be uniquely identified. Each computer is assigned on an internet protocol address, IP address. Long string of numbers allows computers to identify and reference each other. You have fully qualified domain name, FQDN, makes IP addresses with user-friendly names. Domain name service server maintains a list of proper FQDN to IP mappings. Finally, I mean, we have the file and print servers. Linux is well suited for centrally sharing resources, more economical to share files and printers over a network. It is an inherently fast and light operating system. A distribution specific to certain tasks can be installed on the central server. Linux can share resources with a computer running another operating system. The most common service used to allow clients to connect to shared information and printers on a Linux server is Samba. Application servers, you have intermediary between a client computer and information. You can have the database, like organized collection of data that is arranged into tables and related information. You have the DBMS or database management systems, set of programs designed to allow for creation, modification, manipulation, maintenance and access of information from databases. You can have application servers that provide management functionality. The cloud system is also very relevant today. I mean, cloud is a large system of computers that work together to provide a wide set of services to users and organizations across the internet. Example, Facebook, Amazon, Twitter, Gmail, Office 365, PayPal, and eBay. Most cloud systems run Linux in a cloud-based configuration using cloud software, collectively called cloud platform. The OpenStack is one of the most popular open source cloud platform available. The supercomputers, you can have the cluster computing, like combining several smaller computers to act as one large supercomputing system. Um, you can have the clustering, most common Linux method for clustering. You can have the message passing interface MPI. There is a scalability, the ability of computer to increase workload as the number of processors increases. Clustering computers often result in better scalability than adding processors to a single computer. Then the scientific or engineering workstation, scientific and engineering community often needs customized programs. The operating system open source software programs can be used or modified to create specific scientific and engineering workstations. Many OSS programs are available for different branches of science. You can have the office or personal workstation, the workstation software designed for end users in office and home environment. The open source software packages available for graphics editing software or GIMP, desktop publishing software, or that is called Scribus, media software like VLC, financial software like GNU Cache, office productivity suites like Apache OpenOffice, or LibreOffice, the BitTorrent clients like QBitTorrent. You have the mobile devices. Following introduction of the Apple iPhone in 2007, several Linux-based smartphone tablets started to show up in the market. Google Android in 2008 is the most notable. By January 2014, it's old. The Android was installed on over 79% of the smartphones in North America. Other Linux distribution you may be found on mobile system are Bada, Firefox operating system, a lot of others. So, in summary, we can say from this lesson is that Linux is an open source software um, where whose kernel and additional software are freely developed and improved upon by a large community of software developers. It's published under the GNU public license, referred to as open source software. Its companies find Linux a stable, low risk and flexible alternative to other operating system. So if you like this presentation, please give the feedback, comments. If you like it, then please subscribe to our channel. We will have more and more presentation, more and more hands-on tutorials on Linux in the coming days. Okay, thank you for now.